Hey everyone, welcome to the Solving Equations by Graphing video. This is different than solving systems of equations by graphing. That's when you have two equations. If you look at all these examples, you only have one equation. We're going to go through notes and then I'm going to have you guys work on the assignment for practice afterwards. So if I want to solve these algebraically, we should already know how to do that. We've been learning it since Unit 1. We've been having to use it every unit since, at least at some point. So, for example, if your equation was 2x minus 5 equals 3, you would want to add that 5 to the other side, because it's being subtracted. Subtraction and addition will cancel each other out. And that leaves me with 2x equals 8. Then you would divide by the 2 and get x equals 4. So 4 really should be our answer to this equation. Now, this might be an example that's easier by using algebra than graphing, but I'm using it as an example because we know the answer is 4. So I'm going to use that to show you how the graphing works, or that the graphing works. When you want to graph it, you graph each side of the equation as a line. So for example, y equals 2x minus 5 and y equals 3. Now, when I graph these, I'm only worried about what the x value of the intersection is, because I'm trying to solve for x, not y, not x and y, just x. Then I'm just going to graph these two lines. Now, you should know by now that the y-intercept of this first one is going to be the negative 5. So you put a point at negative 5. And then my slope is 2. So I'm going to go up 2 over 1 from that point. And I can do this a couple of times if I want to. Sometimes I just keep going all the way across the page. You do not have to. You can just draw your straight line through the first few if you would like. Then, if I'm going to graph the equation y equals 3, I'm going to go to where y is 3 and draw a line straight side to side, like that. And that means that where they cross is right here, which has an x value of, look at that, 4. Now, where this gets to be a little more useful is this next problem, because if I'm solving this next one algebraically, I would have to make this a 1x and subtract that 1x to the other x on the other side. Since they're on opposite sides, I have to do the opposite. Now, 3x minus 1x is 2x. And then I'm writing down everything else that didn't change. Now, kind of like the last equation, it's almost identical, but it has a 1 instead of a 3. I would add the 5 to the other side. 2x equals 6. And then I would divide by 2. X equals 3. And I'm done. Or I could have graphed it like I'm going to do on the other side. Now, on your assignment, I'm only giving you the option to graph. I'm just trying to show you how these give you the same answer. So if I'm graphing this other one, I'm going to graph y equals 3x minus 5 and y equals x plus 1. You're just treating each side like its own graph. And then my y-intercept, again, would be negative 5. But this time, my slope is 3. So I'm going to go up 3 over 1. Like that. On the other line, my y-intercept is 1. And my slope doesn't have a number in front of x, so it is also going to be 1, meaning you go up 1 over 1. And it looks like they cross right here, where what do you know, x equals 3. Now, on the last one, I'm going to graph instead of solve first. y equals 5x minus 3, and y equals 5x plus 1. Last number is your y-intercept, so this one will start at negative 3. And 5 would be your slope, so you're going to count up 5 over 1. And then the other line, 1 is your y-intercept, but your slope is still 5. So start at 1 and count up 5 over 1. What do you notice? Hopefully you notice that these two lines are parallel, so you have no solution, because they never cross. Now, if I had tried to solve this algebraically, I probably would have subtracted the 5x first, and 5x minus 5x cancels both of these. So I have negative 3 equals 1 left. Negative 3 cannot equal 1, so again, my answer would be no solution. But on the right, we can see proof visually of why some equations have no solution. All right, now what your assignment's going to be more like is these last two. I'm not going to make you solve it twice, I'm just going to have you solve it once, and that's it. So remember that you're going to make y equals the left side and y equals the right side. On the left side, my y-intercept would be the negative 5, and my slope would be the 1/2. So I'm going to go up 1 over 2. Just like that. Oops, my line got a little off, that's all right. On the other equation, my y-intercept is 1, and my slope is negative 1. So I'm going to start at 1 on the y-axis and go down 1, right 1. If it's negative, we change whether we're going up or down. We do not change whether we're going left or right, because most lines, or all lines, should read left to right. And it looks like these two cross right here, which has an x value of 4. Try to keep in mind that the whole point of graphing it is just to find out where they cross, and then you just need the x value. So your answer is not actually the graph itself, it's the x value where they cross. Make that super clear in your answer afterwards. All right, one last problem. Y equals 2/3 x minus 1, and y equals negative 2x plus 5. On y equals 2/3 x minus 1, you have a y-intercept of negative 1. So we'll start on the y-axis at negative 1. And you have a slope of 2/3. So I'm going to count from that point up 2 over 3. The other line will start at a y-intercept of 5, and it has a slope of negative 2. So you're going to go down 2 over 1 to the right. And like that. Now this one can be a little bit tricky. I'm going to zoom in really far to show you. It looks like these two cross right here, which is between 2 and 3. So I'm going to go ahead and say x equals 2.5. And that's the end of the notes.